Are you interested in using AI workflows in Node-RED, but you're not quite sure where to start? Today I'm going to show you a project that uses Node-RED, FlowFuse, and three separate models. We're going to use OpenAI's ChatGPT, xAI's Grok, and Anthropic's Claude. By the end of this video, you'll have a pretty solid understanding of how AI workflows are managed in Node-RED and FlowFuse. Hi there, my name is Kristopher Sandoval. I'm a developer relations advocate with FlowFuse, and I'm here to help you make your workflows everything they can be. Now I'm going to include all of the instructions as well as an export of the nodes on GitHub. And you can find a link to that documentation in the description attached to this video. So with that said, let's dive right in. So before I walk you through building this out, let me show you what the end goal is. Once we're done, we're going to have this dashboard. This dashboard is roughly split into an input area and a response area. In the input area, users can submit a query like, is Node-RED the best enterprise and industrial automation software based on nodes? When the user hits enter, this query will be sent to 6 different AI agents. And these agents are going to respond based upon a certain persona. Once all of the agents have answered, a last step arbiter is going to synthesize all of those answers into a single best answer. The idea here is that a single agent answer can be hallucinatory, but it's rare to have the same hallucination across 6 different answers. Let me show you how this flow actually works. The way we ingest a user query is through a text input node. Now this text input node is from the dashboard. If you don't have that, here's how you're going to install it. Go to the upper right and click on this menu. Now go to Manage Palette. Once you're in this view, click Install and search for Dashboard. Now make sure you install FlowFuse Node-RED Dashboard, as this is Dashboard 2.0. Now assuming you have that set up, let's go look for our node. You're going to look for text input, and you're going to drag text input onto your workspace. Now if you double click this node, you'll see that there's a whole bunch of properties that we can assign it. We're going to give it some pretty basic things like its name, its group allocation, its label, things like that. Now this is really important. When you're configuring these properties, make sure that you uncheck focus leave. What unchecking this is going to do is make sure that we only get the query from the user when they hit enter. Otherwise, we're going to get it every single time that they click off of this area. So with that in place, let's go ahead and click done, and we can move on to our next node. Now, working with these AI APIs require you to be a little bit forward thinking. The reality is that this query is going to go to multiple agents, and if we want all of those agents to have different personalities, then we need to merge those instructions in with the query itself. We basically want the API to see this as if we were sending the query with the instructions at the beginning, like we would if we were chatting natively with ChatGPT. So in order to do that, we need to have the query sent to multiple places at once. The best way to do what we want is actually to use the function node. Now what the function node allows us to do is to take the payload from query and apply some structure to it. Mutate it a little bit to what we want it to look like. We're actually going to use this twice, so go ahead and drag a second function node underneath the first. Now our particular use case makes use of personas. And these personas have very specific instructions. We have Kapoor, who is our financial analyst. Then we have Kylie, who is our legal counsel. Next we have Nora, who is a creative. We have Omar, who is sort of an IT analyst. We have Eddie, who is another creative but is a little bit more grounded. And we have Sam, who is our lead developer. So let's build out Kapoor's instructions first. So to do this, start by double-clicking on function 1. Within function 1, we can set some logic. The first thing we're going to do is set the topic. Now on FlowFuse, when you set message.topic, you're appending a certain value to the message.payload. And then you can filter using that topic. It gives you a great way to control where things are routing and how things are being acted upon. So in this case, we're going to set this as message topic equals 1. And now we want to give it the actual instructions. Now in the description of this video, I've linked you to the GitHub where all of these instructions live, but you can customize them for whatever you want them to do. So in our case, we've set message.payload as the instructions, and they're roughly, please answer this question from a financial perspective, keep your answer between 2 and 3 sentences, etc. Let's go ahead and name this node. I find that naming your nodes as you work on them is a really easy way to make sure that everything stays organized and sensible. Great, so we have Kapoor instructions, and we'll go ahead and click done. And now that node will manage all of the instructions for the Kapoor persona. So now what we need to do is make sure that the query from the user gets carried forward. And in order to do that, we'll use the second function node to assign a message topic to. This is basically just going to be a pass-through node, but it's going to make sure that the instructions are passed first, and then the payload from the query. So just like before, we've set message.topic equals a number, in this case 2, and then we've set message payload equals message payload. We also named this set topic value just so we know what this function actually does. So let's go ahead and click done. Now let's wire all of this together. And just for testing purposes, let's go ahead and add an inject node. That's going to let us see what actually happens when we process this. Let's also add a debug on the other side that gets both Kapor instructions and set topic value. All right, now let's click deploy to put this live. Now, if we hit the inject button, what do you think you'll see? What we should see is a timestamp generated and sent through the query node. We should then see in the debug window two things. We should first see the instructions passed, and then we should see the timestamp as generated by the injection node. Let's see if that happens. Let's go ahead and click, and here we go. We saw exactly what we wanted to see. Now you'll notice that when this came through, we saw exactly what we wanted to see. The first message was the instructions, and the second was the payload. That's going to be the crux of how this whole system works. For now, I'll only build out one agent, but in theory, you could expand this to thousands of agents. So let's do the rest of the agent process. First, let's clear our debug column, and let's get rid of the debug node. Now that we have these two function nodes generating a payload, we want to join both of them into a single payload. And the easiest way to do that is by using the join node. Now the way the join node works is basically taking multiple inputs and combining them into one depending on some rules that you set. So let's start by wiring Kapor instructions and set topic value into our join node. So what we need to do here is change this from mode automatic to mode manual. We'll go ahead and name this Kapor join. We'll make sure that we're combining the message payloads and that we're creating a key value object using the value of topic as the key. Now what this is going to do is it's going to take the topic 1 with payload 1 and the topic 2 with payload 2 and make it into an object that can be parsed. Now we want to make sure that we're getting both parts of the message, so we're going to change count to 2 and unclick every subsequent message. And now click done. So let's bring our debug node back into our workspace and see what this looks like now. If we go ahead and click deploy and then inject using our inject node, we get a single payload object with both payloads. Great, we're halfway there. So our next step is now to take that merged payload and make it something that the API can actually see. And the way we're going to do that is pretty simple. Let's move the debug away and remove its connection. Now what we're generating through the join node is actually a JSON object, which is great because we have a JSON node that can change that into a string. So let's look for our node called JSON and drag that onto the workspace. Now connect these two and open up the JSON node. Now here we have a couple options. What we want to make sure is that the action being taken is always converting to a JSON string. We don't want this to be two separate payloads. We want it to be one payload that can be parsed by the API. So now that this is in place, go ahead and click done, and let's connect this to our debug and see what we get. We'll go ahead and click deploy, and now let's click inject and see what we get. So now you can see why we've done this. The top result is what we got from the original process of using the function nodes. We got two distinct objects. Now we have a single string that we can feed forward to our API. So let's go ahead and remove our connection, and we'll start on our API formatter. Now the thing with a lot of these AI APIs is that they require a very specific format and function in order to parse these requests. So what we need to do now is take this string that we generated from our JSON node and turn it into something that the API can actually ingest. And we'll do that with another function node. So let's go grab our function node and drag it onto our workspace and then wire up these nodes. Now Kapor is one of our agents that uses Grok, but you can use any AI API for this process. Now this is the format that Grok expects. We're going to use message.payload to pass our join string as the content in the API request. Now this is defined in the API documentation that I'll link in the description of the video. Let's go ahead and click done. So to see what this looks like, let's connect it to our debug node. Let's deploy and click on our inject node again. All right, awesome. We can see exactly what we're generating. We can see that we've generated the object that the API is expecting. Our message is clearly defined, our content has the string that we generated earlier, we've specified the model, and we've even specified the temperature. So in order to get this out of Node-RED to the API itself, we're going to use a pretty powerful node. This node is called the HTTP request node. So go ahead and click that node and drag it onto your workspace. Now what this node allows us to do is to make a request to an external API. So let's go ahead and fill out everything that we need. Now according to the documentation, this API request has to be a post request. We'll make the request to the completions API, and we'll make sure that what we get as a return is a parsed JSON object. Now we need to add the headers. So the first thing we need to do is add our content type header. Now we need to add our authorization header. Now we can hardcode our authorization into these flows, but that's not really security best practices. So let me show you how to do this the right way. For now, we're going to add the header as authorization, and we're going to define it as a global variable. in this case, Grok. Let's go ahead and click Done and then deploy. Now go back and look at your instances that you're hosting on FlowFuse. Select the one you're currently working on and click Settings. Once you're in Settings, navigate to Environment. What you can do is basically add a variable, and you can set that variable to any name and any value. And then when you click this eye icon, you're basically hiding that value from anyone who has access to the instance. And in this way, you can store things like API keys, login credentials, really anything that you don't want people to be aware of or see in your flows. In this case, we've already set variables for GPT, Grok, and Claude. So let's get back to our workspace. Okay, awesome. So now we have our system that will send out our request. The thing is that when we get that request back, we need to actually parse it. Let me show you what it looks like right now. If we go ahead and click inject, we'll go ahead and get an alert that Grok is processing our request. All right, awesome. We got a response back from Grok. Let's go ahead and look at that message payload. The thing is that there's a lot of stuff here, and in order to show the actual completion, we need to parse it in some way. So to do that, we're actually going to use our change node. Now the cool thing about a change node is that we can change a payload into anything, but we can also do the inverse. In other words, we can extract the message payload from anything that we got back from Grok. And we can see that the actual message is defined as payload.choices0.message.content. So let's go ahead and set our payload to that value. Now you need to make sure that you set this not as a string, but as message.payload.choices, etc. So go ahead and click Done and deploy. Now if we click the inject node and wait for Grok to process, we get our response from Grok parsed as a single string. Okay, so let's go ahead and clean this up a little bit. Now the cool thing is that this exact flow can be copied over and over for every single API instance. I'm going to go ahead and do that now for all the models that we want to touch. Okay, now we have our cleaned up workspace. You'll see that I use a particular node called comment. Now comment allows you to put comments around anything. And I often use it to show how things are organized. That way this is maintainable even when I'm not the one maintaining it. So with that in place, we have our Grok queries, our ChatGPT queries, and our Claude queries. But in order to get this to output text in any meaningful way, we need to give a place for the responses to actually be rendered. Now to do that, we're going to use the dashboard. We'll go ahead and use the text dashboard node. Now what these nodes allow us to do is to take our message payload and render it as text on a dashboard. So if we connect this to Grok and then configure it properly, we'll be able to make sure that anything that gets generated from the Kapor flow renders in the area where it says Kapor says. And now that we have this in place, we can actually replicate this for all of the requests. Okay, now we have our basic functionality. If we were to ask a question, we would get all 6 responses back. We can say, "Hi there, are people enjoying this video?" And we'll be able to see their responses in real time. Although those responses obviously aren't very useful right now. So with that in place, we need to do the next step, which is the arbiter logic. Now, obviously, we want all of these responses to be fed into a single arbiter who can combine all of this feedback into a single, valuable, useful response. So let's go ahead and do that now. The good news is that we have everything in place to do this, but we need to do a little bit of remixing. If you remember when we were first building these queries, we had to put the instructions first and then the actual query second. And we have to do the same thing with all of these requests. But instead of just having one request and one instruction, we now have 6 queries and 1 instruction. So first we're going to have to build out the logic that allows us to integrate all of this feedback into a single answer. So first we have to build out all of the logic that's going to let us integrate this into a single string. And the way we're going to do that is by starting with a function node. So the first thing we want to do is make sure that message topic 1 is actually our instructions. So open up the function node and use this specific logic. We're going to change message topic to 1, and we're going to give it a payload that basically instructs the arbiter on how to behave. As we saw during testing, Grok was much slower than everyone else. So we want to make sure that this function gets triggered when everything is ready. So in order to do that, we're going to use the trigger node. Now this node can be configured to do a lot of different things. For our use case, what we're going to have it do is send the existing message object. Then we're going to wait for 250 milliseconds, and then we're going to send a piece of text. I'll show you why in a minute. In this case, we're going to have it just say arbiter has sent a message, and we're going to make that second message go to a separate output. Now with that in place, we're going to take our slowest model, which is Grok, and we're going to connect that directly to the trigger. The trigger then has 2 outputs. The top output is what we're going to route to our console context. We're then going to take the second output of the trigger and route to a debug. And that's basically just going to tell us that this is actually working. It's really helpful to make sure that throughout each of the steps when you're building a flow, that you're giving yourself options and points to test. Okay, now we need to unify all 6 of the original queries with this new context. And the way we're going to do that is to create a bunch of function nodes. Now these function nodes are going to help us integrate the messages by setting the message.topic to a specific number. Now I've set these up behind the scenes, but let me show you how 2 of them are configured. You'll get why 2 in a minute. So first let's look at the Kapor integration. When we're handling a message from Kapor, what we're going to do is set message.topic to 2 and then carry forward the message payload. If we look at the way that Kylie's is set up, we're going to set that topic to 3 and carry forward that payload. Now all of these integrations are numbered in that fashion. Council context is given message topic 1, Kapor is given message topic 2, all the way through Sam, which is given message topic 7. And when we route the integrators to their specific persona, what we're going to have is every message payload from each model given a topic value, which we can then use to stitch together that message. And to stitch it together, we're going to use join. So go ahead and click the join node, drag it onto your workspace, and wire up all of the function nodes to join. Now again, we need to set the join to manual, make sure that it's handling message.payload, make sure that it's using the value of message.topic. But now we're going to uncheck every subsequent message, and we're going to set the number of message parts to 7. What that's going to do is it's going to take all 7 parts of our message and join it into a single message to be sent forward. Let's route this to our debug and see what we get. Now as usual, everything except Grok has finished. But once that finishes, you're going to see a bunch of outputs. And this is exactly what we wanted to see. First, we have the message payload that's coming from Unified Council 7. Here we can see all 7 messages put in object form. And then we can see that extra debug output that we put on the trigger that basically just confirms that arbiter has sent a message. Now this section is much of the same, so I'm not going to go through each node. But in essence, we're taking Unified Council 7, we're taking it to the JSON node parse council, then we're feeding that into a function node called GPT formatter that basically takes everything that we have and sends it as a payload to GPT itself. Next, we're feeding that into an HTTP request node, and we're sending a post to the OpenAI API. Once we get that response back, we're feeding into Parse GPT, which again is a change node, and that node is just taking the payload output content text, which is how the ChatGPT API gives us our response, and we're converting that over to message.payload. Now you can take that and render it as text. If we were to ask this council a question, say what is the best time to release a YouTube video, what we'll see is all 6 models trying to respond to that question and then feeding their responses to the arbiter. Awesome, we got all 6 answers from our models and we got the final arbiter output. So this is already pretty cool, but there's some quality of life things that we need to do. The first thing is that the user doesn't actually know when their request is being handled. They hit enter, but they don't know that the API is processing their request. So let's go ahead and fix that. Now change nodes are very powerful, and we're going to use that to our advantage. The first thing I want to do is drag the text node onto my workspace. Now what this text node is going to do is give us a way to render to the user that their request is being handled. I've gone ahead and built this text node out, but basically what we're doing here is we're labeling it that Kapor is ready before a request has even come through. And by using a change node, we can change the label that this displays. So let's go ahead and click deploy and see what it looks like right now. So all we see right now is the phrase Kapor is ready. And what we'll go ahead and do is add a change node. Now using this change node, we're going to set the message.UI update label. Now the UI update label is just going to update what text is shown when a certain thing happens. It might sound complicated, but let me show you what it looks like. We're going to make sure that the message.UI update label changes to the value Kapor is thinking. And we'll tie the input for the change node to the output of the initial query. Then we'll connect the change node to the text node. So what this looks like now is that we have the experience that we already had, but when you send a request, we're going to update while the model is thinking to the phrase Kapor is thinking. But of course, we don't want it to just say Kapor is thinking. We want the user to know that the request has been handled properly. And in order to do that, we're going to use another change node. Just like before, we're going to set this to change the message.UI update label, and we're going to change it to say Kapor has answered. Now we're going to route this to the same node that says Kapor is ready and Kapor is thinking. But this time, we're going to route the input of this change node to the output of the parse. What this basically does is when a query is submitted, it updates the label from Kapor is ready to Kapor is thinking. And then at the very end of that flow, once it's parsed, it again updates the label to say Kapor has answered. Let's deploy and test this out. So now that we've asked our question, we'll go from Kapor is thinking to Kapor has answered. So let's replicate this for all of the other agents and clean this up a little bit. All right, awesome. We have our complete flow. So this top bank is basically going to update the label to say that our agent is thinking, and then the bottom bank is going to update that they have answered. And we can take the exact same logic and use it for the arbiter. That way we can know whether the arbiter is ready, thinking, or has answered. Awesome. So now we have our complete flow. We have our initial query, which is then fed into the different models. We join the query with instructions for each model. Then we convert that into a string. That string is then formatted for the API, is then sent to the API, is then parsed, and is sent to the individual outputs. These outputs are then collected as part of a council response collection system, which is then fed to the final arbiter. And to make it better for the user, the initial query updates the text label to let you know that the models are working. And then when a response is generated via the parsers, we update that label again to let you know that the model has answered. And we can replicate that exact same answer logic to the final arbiter. And when deployed, it looks something like this. So we can ask this any question that we want. We can ask it a question like, why is Node-RED so awesome? Right when we hit enter, everyone started saying, hey, we're thinking. Here we know that everyone has answered except for Kapor. But once Kapor answers, that is then fed to the council, who answers as the arbiter of all things that have been said. So here's the really cool thing about this flow. This is entirely extensible. You can make this for thousands of agents, but more importantly, this means you can also connect these sorts of agents to industrial data. You might have sensors detecting something like supply pressure, downstream pressure, and backflow. Now, because of the nature of fluid dynamics, you might have a shock column, or something that makes it hard to detect where a failure actually happened in a complex series of sensors and systems. Using a system like this, you can collect all of that data and give it to different agentic solutions that are concerned with very particular things. Maybe one agent has all of your specification data. Maybe another agent is particularly interested in fluid dynamics. Maybe there's a third agent that is monitoring power fluctuation. And you can ask all of those agents to combine their understanding, your specification data, and your sensor data, and try and come up with the best answer for your given problem. And that's hugely powerful, because you bypass a lot of the issues with having a single model that could hallucinate. Now, yes, this does mean that you could have 6 models that hallucinate, because you have more systems working together towards a common goal. And where Grok is weak, GPT might be strong. Where Claude is strong, GPT might be weak. And in the end, you get a response that is better than the sum of its parts. Now, this is obviously a hugely powerful workflow. You can use this for everything from predictive maintenance to cross-site analytics. And the more agents and data sources you put into the system, the better you can make the final output. I hope you found this flow useful. If you look in the description attached to this video, you'll find a GitHub that contains all of the instructions as well as the JSON import that you can use to bring these nodes into your workspace and experiment today. I hope you found this content helpful. If you did, please give us a like, comment, or subscribe. Please check out the FlowFuse and Node-RED community forums and our Discord and Slack. Thanks for watching, and I'll see you next time.